Welcome, y'all. Back to some more geometry. Today we're talking about three-dimensional figures. Three-dimensional. So we're talking about length, a width, and a depth. Alright, so three-dimensional figures are what we call common polyhedras. Polyhedras is just fancy for a shape that has multiple planes, multiple surfaces. We have what is called platonic solids, our prisms, and our pyramids. We're going to go through all those sort of to a point. Alright, so polyhedron solids are solids with flat surfaces that enclose a single region. So they go around a certain space. So there's empty space in between all this right here. If there was a, say this triangle was not here, this surface was here, then no longer be a polyhedron because you have this free flowing area. You have a polyhedron-ish type shape, but it's not be considered polyhedron. So faces on a solid are the sides. So all these flat sides right here are our faces. So for example, this triangular prism has 1, 2, 3 that go around, and then one on bottom, one on top, 3, 4, 5. 5 total faces. Right? The edges are again the side, these little straight areas, and then our vertex are the points, all the individual points. Those are our vertex. Now, to be more specific on the faces will be considered the sides. The bases are the other two bases, the other two faces. Bases, yes. So let's kind of go through those. Common polyhedrons will be something like triangular prisms, square prisms, rectangular prisms, pentagonal prisms. Any question why these are called triangular prisms, a square prism, a rectangular prisms? Yeah, because the bases are named by the shape of the base they have. For example, this is the base of this prism, so it's a triangle. This is the base for this one, so on and so forth. Pentagonal, hexagonal, and so forth. So if we have a 12-sided figure, 12-sided, ooh, that's horrible. But it's a 12-sided prism. This would be called a dodecagonal prism because a 12-sided figure is a dodecagon. Same thing with pyramids. Pyramids are named the same manner. A triangular pyramid, a square pyramid, a rectangular pyramid, pentagonal pyramid. Now, let's talk about the faces. On a prism, there's the number of faces as they are on the number of sides on the base. So there's 3 sides on the base, there's 3 faces, and there's 2 bases. So this has 2 bases, and multiple faces. The faces it varies depending on the sides. Here, what makes this a little bit different is we got one base. We always have only one base, and the other side will always go to a point. Now these are called common polyhedrons because they have bases, faces, sides, and vertices or vertex. These right here are common non-polyhedron. They're non-polyhedron. Why? Anyone want to take a random guess why? Similar to a circles, they have no sides. There's no sides to this right here. There's no sides to this sphere. There is a point. We do have vertice here. We have no vertice here. We do have 2 bases, but then the rest all around, there's no sides. So these are the main ones that we'll deal with right here. All these right here. All right, so let's kind of go through this. So the surface area is the space on the outside. So if you think about this, if we had a cube here that we'll call it a prism, cube or prism, a rectangular prism right here. When we paint the outside, that's the surface area, the outside part of it. And we just add all we find the area of all the individual faces and add them up. Or there's actually a way to kind of do that. Now, the volume is what's inside. What's inside? If I were to fill this up with water, how much water will this hold? That is the volume. So there's 2 different things. So we'll go through both of them slowly. So we'll start with prisms first. Prisms, again, are made up of 2 bases and multiple lateral faces. Now, on the lateral faces, what kind of faces are all these faces right here? all rectangles. They're all rectangles. We have a triangle prism because it's the triangle base, but all the faces are rectangle. Square prism, but all the faces are rectangle. Pentagonal prism, but all the faces are rectangles. Okay, so it's very important to kind of notice that right there. We notice that. All right, so let's start with the surface area. The surface area of any prism, regardless of what kind of prism it is. Excuse me. Surface area of any prism is the perimeter times the height plus 2 times the base. So like we have here, P stands for the perimeter of the base. Just like before, whatever part is on the bottom, that's our base right there. That's the base. So we have two bases here. We have this top one right here and this bottom one down here. These are our base sides, base faces. So we take the perimeter of that. We then take the height. The height will always be the distance between those two bases. So if we call this, let me change colors. If we call this a base and this a base, then this right here becomes our height, the distance between the two bases. But on this particular shape, we use the top and the bottom, and this is the height, this length right here. And the area of the base, again, we just take one of these bases and we find the area of that. Anytime you have a capital letter, that usually in math stands for something more than just that particular thing. See, a small letter represents just a solid one thing, a height. A P, big P, stands for perimeter. It means multiple parts are being added or put together. And a big B stands for area. It means we're going to multiply two sides to get that. So let's kind of do that first. We'll do the surface area. So let's take this shape. So if this is 10 right here, that means this side across from it is also 10. If this is 5, this is 5. So our perimeter here, our perimeter for this shape is 10 plus 5 plus 10 plus 5, 10, 20, 30. Our height, of course, our height is denounced by the distance between the two bases, this right here. That's our 6. And then the area of the base, well, it's a rectangle, and as we talked about in section 1.6 about two-dimensional figures, to find the area of a rectangle, you take base times height. So the base of the rectangle times the height of the rectangle. So side times side, length times width. 10 times 5, 50. Yeah, 50. All right, now we got all the parts we need. There's 3 main parts we need right there: our base, our height, and our perimeter. Now, let's find the area, y'all. Surface area. So, surface area equals our perimeter, 30, times our height, 6, plus 2 times the base area, which is 50. Now, before we do this, I want to break down this a little bit more. I want to explain this a little bit more. When you're doing the perimeter, you're adding all the sides right here of the actual faces, and then they all have the same height. So you're just doing length times width of all the faces. Just happen to do it all at once because we took all those faces times the height of all those faces. You got that? We call this the lateral area. We'll talk about that much more later in second semester. All right, but back to the problem. So we take 30 times 6, you get 180, plus 2 times 50, which is 100. So surface area equals 180 times 100, plus 100, you get 280. 280. And that's units square, because it's area. Even if it's surface area. Surface area equals 280 units square. Ooh, excuse me. All right, let's look at volume. Volume is so much easier. These numbers, these letters still represent the same thing. Big B stands for area of the base. H is the height. So we already have those numbers. Volume equals 50 times 6. 50 times 6. What did we get there, class? Yeah, 300. Now with volume, it's units cubed, because we talked about volume is a 3-dimensional measurement. You're looking at the width and height and length and depth of a shape, the inside, all 3 parts, so units cubed. Good job. All right, this one's yours for you guys to do. This is a square. So a square is so much, very the same concept here. Area of the base, so side times the height. But and it's 6s squared, because we're going to break this down like the other one. We do perimeter times height plus 2 times the base area. Well, perimeter is side, 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 side. So it's 4 sides times another side, 4 sides times another side, plus 2 times side times side. It's crazy. So 4s times s is 4s squared. 2 times s plus s is 2s squared. Add them up, you get 6s squared. So instead of just making it super complicated, we're going to make it really easy. If it's a cube, if you know all 3 dimensions are the same, just take side times side, square that first, and then times 6. You're done. Volume is even easier. You just multiply all 3 parts, side times side times side, and you get your volume. Okay, you'll run into that. This is a very unique shape. Cubes are kind of like the building block to all the other shapes. You can create all the other shapes using little cubes. That's why we say, hey, that's 30 units cubes. Because the question is, how many little cubes can I fit in here? Because this is the almost, not the perfect shape, but it's close to it. Everything fits in here. Everything's the same length, width, and height. All right. So that's just the gist of that. Let's look at pyramids. So pyramids, just like the prisms, they have bases and lateral faces, but they only have one base. Now, what kind of lateral faces are these right here? Where are all the faces? Oh, triangles. Triangles. What's unique about triangles is that they have the formula base times height divided by 2. So that's going to come into play here. Let's look at that. Ooh, right here from the very beginning. So on a surface area, still the same concept. You have a perimeter, you have a height, and you have a base. This L, though, it's an L, not a 1. It's an L. It stands for slant height. There's 2 different heights in the pyramid, and we'll talk about both of them in a bit. So let's start with the first one. So for surface area, you do perimeter times height divided by 2. Similar, because when we do perimeter times height divided by 2, we're looking at the area of the triangles. Area of triangles with an S, triangles, because it's multiple. So this is the area of the triangles, multiple triangles. So perimeter of the base, so that plus that plus that plus that times our slant height. Our slant height, there's 2 heights. There's the height of the actual prism, like how tall the whole thing is, pyramid, sorry, how tall the whole thing is. And there's the height of the face to the point from the surface. It's slanted. That's what we call that slant height, L. Or lateral height, the side heights. That's what we use an L kind of to represent that. B is still the same, area of the base, so it's just side times side or length times width, depending what kind of base it is. And then the height of the solid, we'll use that for volume, and we'll see why. So this is on the surface, so we do a surface height, the lateral height. So for example, down here, let's find all these parts. So perimeter, slant height, area of the base, height, and we'll use it for both of these problems because it's the same one. So we'll start with the area of the base. So that's 6, and we're assuming this is a square because they only gave us 1. That means this is 6 as well. And assume these are all 6. So perimeter is 6 plus 6 plus 6 plus 6, 24. Our slant height is this size 1 right here. That's our 5. Area of the base will be side times side, 36. And then height of the solid is how tall the whole thing is. It's a 4. Alright, so we'll start with surface area. So first area is equal to 1/2, or we're going to do perimeter. We'll do 24 times the lateral height, 5 over 2. You can also write like that. Plus the area of the base, 36. There. So let's reduce this. 2 goes into 24 how many times, y'all? 12 times. Yeah, and then 12 times 5, 60. That's 36. We add those up, surface area is equal to 96 units square. Good. Let's look at volume. Volume is in thirds. Volume is in thirds. And when we get to we have a whole chapter on 3-dimensional figures, we'll see where that 1/3 came from. But it's all based on a prism. It's all based on a prism. So just like before, volume represents the area inside all this, inside. So if I were to fill this with water, how much space would this take up? So that being said, when we're talking about height, we're talking about the height that goes inside. Do that in red. At 4 right there. Let me erase this. Looks ridiculous, y'all. Ridiculous. There we go. So when we talk about height, we talk about the height that goes inside. We're not talking about the surface. We're talking about the volume, the height that's inside. That's why we have a different height. But same idea here. We do area of the base. So volume is equal to, and we can also write it as base times height over 3, like that. Base times height over 3. So that's equal to the area of the base, which says 36, times the height of the solid, which is 4, all over 3. That, and 3 goes in 36. Thank goodness. 1, 2, 12. 12 times 4 is 48 units cubed. 48 units cubed. Much more simple. Now, even though this number numerically is bigger than this amount is much more greater because of these units cubed. Units cubed. All right. Let's talk about our non. Ooh, excuse me, y'all. I haven't had enough coffee. Talk about cylinder, our first non-polyhedron shape right here, solid. So the idea for this is the same. It has two bases and a lateral and faces. It's just one big face. If you were to cut this up into parts, you have a circle, a rectangle, and then another circle. If you were to open this surface, lay that out, and open that surface, it'll look something like this. That makes a rectangle. That rectangle happens to be just as long as it is around the circle. Fun fact right there. We'll get more into that later in this chapter, or later in the book. All right, so on here, there's two main things we need: the radius and the height. Pi is still pi, and we'll keep our answers in terms of pi throughout most of this, because I think it does also in your book, but we'll go ahead and also find the non-pi answer as well. We'll start with surface area. So our radius on this particular problem down here, or the radius, is always on the circle, goes from the center out, and the height is always the distance between those two circles, how tall it is. All right, so for this particular problem, we have a radius of 9 and a height of 20. Radius of 9, height of 20. So surface area is equal to 2 pi. What's our radius? 9. Yes. What's our height? 20. Plus 2 pi radius, 9 squared. So let's work that out. So as order operation says, take care of exponents first. Parentheses, and then exponents. So exponents, 9 squared is 81. So we got 2 times pi times 81. And then 2 times pi times, multiply 9 times 20. 9 times 20 gives us what, y'all? Yeah, 180. 180. Now, let's go ahead and keep it in terms of pi for now. So we're going to multiply just numbers. So 2 times 180 gives us 360 pi. Plus 2 times 81. This is 162 pi. And then you can add those up. Because they both have just a single pi and their numbers, just like anything else, because they have the same unknown here, you just add them like normal. So 360 plus 162, that gives us 522 pi. Now this is an acceptable answer for surface area. 522 pi units squared. But let's go ahead and actually multiply that. So 522 times the pi, you can use 3.1415, and we're getting 1,639. I use pi, so it goes 91136. I'm going to go two numbers, 911. So it just gives us 91 units squared. 91 units squared. All right, let's look at volume here. Volume. So I'm going to erase this, so if you guys want to write this down, you can pause it. I'm going to erase it for now. Because we need the space, y'all. Let's do some math. All right, here we go. So we're looking at volume. Volume still uses the same parts, the radius and the height, just adds a little bit more fling to it. So we're doing pi radius square times height. Pi radius square times height. Hey, what formula is just this part right here? Pi radius square is the area of a circle. So we're taking the area of a circle times the height. And that's what volume is. Area of the circle times the height. So volume equals, because look real quick, last one, area of the base times the height. area of the base times the height. It's crazy, mind-blowing. Yes. So volume equals, in this case, pi times our radius, 9 squared, times our height, 20. Remember, we do exponent first. Do volume equals pi times 81 times 20. Pi times 81 times 20. So we do that. 81 times 20, you get 1,620 pi. So volume equals 1,620 pi. Now this is units cubed. This is an acceptable pi answer, but if it tells you to round it, you take that 1620 times pi, you get 5,089.3800, so we'll 38 units cubed. So that's our volume here, y'all. Volume for this particular cylinder. It's big numbers, yes, but it's really not that bad. All right, let's keep on going. Our second to last shape we're going to talk about is a cone. Similar to a pyramid, we take the area of the base, and there's a slant height. Same thing. So this is a formula for a cone. It's pi RL, so pi radius slant height L plus pi radius squared. And then height, well, weird word specifically for volume because the height of the entire shape, inside shape. Alright, so let's kind of work this out the same way. Let's, did I not give you numbers? Oh, did I give you numbers? I'll give you numbers right now. Let's go with 5, 12, and we'll say this is 13. Yeah, those are perfect numbers right there. 5, 12, and 13. So it tells our height is 12, our slant height is 13, and our radius is 5. Our radius is 5 right there. So that being said, let's go with the surface area. So surface area, I'm going to do this over here. Surface area equals our pi times our radius times our slant height plus our pi times our radius squared. So exponents first, so 5 squared is 25, so we get 25 pi over here. Okay. We multiply that, we get what, 65 pi? Surface area equals 65 pi plus 25 pi. We add those up, we get 90 pi. This is units square. Again, this is an acceptable answer. Let's go ahead and round this to 2 units in case they ask you. So we multiply that, 90 times pi. Always use the pi button, whether it's on your calculator or on your phone, use the pi button. And I think all phones, I know on Android, you just hit 90 pi, then hit enter. On the iPhone, same thing, 90 pi, then hit enter. You end up getting 282.743, so it'd be 74 units square. All right, let's look at volume now. Volume, very similar. Area of the base, pi radius squared, times the height divided by 3. Very similar to this up here. Area of the base times the height divided by 3. Very, very similar. Same idea. And we'll learn more about that. But pi radius squared times height, all we need is the radius and the height. We don't need the slant height because that's for the surface. So we'll do pi times our radius, which is 5, squared times our height, which is 12, all over 3. So exponents, 25 squared. So 5 squared is 25, so we get pi times 25 times 12 divided by 3. And let's go and reduce this. The great thing about this 3 reduces into this 12 because it's a 4. And then all we multiply is 4 times 25 times pi. End up getting equals 100 pi. This will be units cubed. Now, when you round, that's what these little squiggle means. It means approximately about this much. It means you rounded it. So 100 times pi, 100 times pi gives us 314.159. We're going 2 decimals, so it'll be 16 units cubed. We're doing volume here, so it'll be units cubed. All right, y'all, that's a cone. And last but certainly not least is probably my favorite shape, the sphere. Why is it my favorite shape? because that kind of looks like a sphere, but that's okay. Now, similar to a circle, a sphere is a bunch of points all equal distance from one center, but it's not just going in a two-dimensional, but it's three-dimensional. So a bunch of points all the same distance from this one exact point. Let's kind of look at that. So for surface area, we have what's called a grand circle. The biggest possible circle, there's two of them. There's one that goes side like that and then up and down. Really, anytime a circle is drawn that goes through the center, that's called the great circle. Great circle. If I were to cut this in half, that would make a perfect half right there. If I cut it along this circle, it would be a perfect half. Now we base this on that. Now the reason we talk about that is because you can also make a circle right here. And it's a circle, but it's not the biggest possible circle. It's a circle kind of floating above. It's like having a small dish above a big dish right there. Now for surface area, we do 4 times pi times radius. And for volume, is 4 pi radius cubed divided by 3, or also you might also see like this, 4/3 pi radius cubed. I like to leave it as a fraction like that. Now, the only unknown that we need to know for this whole problem is just the radius. If you look at both problems, everything has some sort of value, 4 pi, radius cubed, radius squared. It's the radius. The only thing we don't know is the radius in both of these. So here in our problem, the radius is 7. So we'll start with surface area. So surface area is equal to 4 pi 7 squared. 7 squared. So 4 pi 7 squared. So that gives us exponents for first 4 pi times 49. So 49 times 4. That gives us 196 pi. That's unit square again. If they want you to do in terms of pi, that's a perfectly acceptable answer. Let's look at what the round answer for that would be. 196 times pi. Get roughly 615.751, so it'll be 7 pi. It'll be units squared. Easy peasy. Let's look at volume. Volume is equal, let me change colors. Volume equals 4 pi times 7 cubed. Got to remember the cube. That's one part that, as I gone through the many years of teaching this class, is this right here. We forget that one's a square, surface area, and one's a cube, volume. Got to remember that. So we start by exponent first. So 7 times 7 times 7. So 7 cubed, 7 times 7 times 7 is 343. So we have 4 pi times 343 cubed. Now, fun fact, the way you know if a 3 can divide it into a number is if you add these numbers and they equal a number that's divisible by 3. So for example, if I take the number 1, what's a good number? 120. 120 is a good number. 1 plus 2 plus 0 equals 3, and 3 can divide 3, so that means 3 can divide 120. So 3 can divide 4, so let's look at this. 3 plus 3 is 6, plus 3 is 4, that's 10, so 3 cannot divide that. So if it can't divide either one, more likely it won't divide the whole number. So we'll look at what that looks like. So then we just go ahead and multiply. 4 times pi times 3, so just 4 times 343. 4 times 343, that gives us 1,372 pi over 3. Add these up again. 1 plus 3 is 4, plus 7 is 11, plus 2 is 13. 13 is not divisible by 3, so nope. This right here will be the exact answer, the non-decimal. So this will be units cubed, units cubed. Now, if you want to go ahead and reduce this, what we'll do is take 1372 times pi first, then divide by 3. So 1372, so times pi gives us 4,310.263, and then divide that by 3. So that gives us, I'm going to do step by step so you guys can kind of have an idea. You get 4,310.265. I'm going to carry a couple numbers, 26512, and then all over 3. Divide that by 3. Your answer should be roughly 1,436 0.755 or be 7.6 units cubed. That's the decimal answer for this problem right here. Okay, this is what we call the exact one. Likely, you could probably leave like that and it'll be correct. So if it tells you to round, then do that. But if it doesn't, leave it like that. And that's it, y'all. Hope you have a great day. I'll catch you on a different day. Bye.